Okay, so this is problem number 2 on Hooke's law in the elevator. You're going to have a spring that's hanging in equilibrium. You have to figure out the spring constant, which is your K. This is going to be just like your lab. So we're going to do force of gravity, which is mg, and the force of the spring. Force of the spring is kx. All right, so how do we start off? We draw a free body diagram. Now we say F net equals ma. A equals 0 because it's balanced. The sizes of the arrows are the same. Same size arrows or vectors. So balanced. That means A is 0. So now I can say F net equals 0. What are my two opposing forces? The force of the spring plus a negative force of gravity equals 0. I add force of gravity to both sides. Now I can say, ooh, that's a crazy thing. All right, force of my spring equals, that cancels out, Fg from over here. All right, now I'm going to erase that. I pause. Okay, now I have showed that the force of the spring equals force of gravity. I replace these variables. I say Kx equals the force of the spring, and the force of gravity is now mg. All right, what am I solving for? Well, let's start listing our variables. We have m, 10 kilograms, has to be in kilograms. We have the x, that's the elongation or the stretch of the spring, is 4 centimeters. 4 centimeters, 1 meter divided by 100 centimeters. Centimeters cancel out. Final unit is that, so it's 4 divided by 100, which is 0.04 meters. Okay, and then my g, of course, we know g as gravity as 9.8 meters per second squared. Okay, so I've erased the board. Now I have to say I'm solving for the k. So how do I get rid of the k? I have to divide by x on both sides. X's cancel out. And now I can say k is equal to mg divided by x. I'm going to have mass, 10 kilograms, times my 9.8 meters per second squared, divided by 0.04 meters. You have to have meters. This here and this here make a Newton. And your final answer, K, will be blah Newton meters.